welcome to the sine rule. Just before we start, a reminder that there is a notes jotter available for the video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so the starting point for this topic is actually the formula. We need to learn this formula as it won't be given in the exam, but it is expected that you'll be able to use it. And it begins with the formula version for finding a side in a triangle, which is A over sine A equals B over sine B equals C over sine C. Or if you want to find an angle, just in order to make the actual calculations a little bit easier to do, you can flip all of that over and we get sine A over A equals sine B over B and sine C over C. And it all comes down to the way that a triangle is labelled. Now in this case we are dealing with triangles which are not right angled. This is only used when we don't have right angled triangles, and basically each angle is named with a capital letter A, B and C, and then the side which is opposite it has the smaller version of that letter. So capital A with lowercase a, capital B with lowercase b, and capital C with lowercase c. Now we have the formula which says A equals sine A equals B over sine B equals C over sine C. We don't actually require all three parts for the formula. We only ever use two of them at a time, but it's just so that we can relate a ratio to each other. So the two values should be equal to each other when we work with it. So let's have a go at a question. Here is a triangle. We know that one of the angles is 60 degrees, one of the angles is 40 degrees. We have a 4 centimetre side, and then we have another side which we are looking to find. And so the first thing we need to do here is just check, do we have a cross? Can we match one angle to the side next to it, side opposite it, and another angle with the side opposite it? Well, in this case, I can match the 60 degree angle with the 4 centimetre side, and I can match the 40 degree angle with the side we know as X. And so that means we can use the sine rule. And so next comes actually labelling the diagram. So all I'm going to do is I'm going to pick either of the angles to be called A. And I'm going to go at the top. So the top angle is capital A, which means that the side opposite it is small a. The next angle I'm going to call capital B, and therefore the side opposite it is little b. You'll notice we don't actually have C involved. That is absolutely fine because we don't know the other angle and we don't want to know the other side, and therefore the two that we've got there are absolutely fine. We're going to use our formula for finding the length of a side. Well, that was A over sine A equals B over sine B. And we're just going to fill in the values that we know. And so little a is 4 over sine of capital A. Well, capital A is 60. And that is equal to B. Well, we don't know what B is. It's just called X at the moment. But we do know that capital B is 40. And so if I need to find X, then I need to multiply both sides by sine 40. And so if I do that, multiply both sides by sine 40, I get 4 sine 40 over sine 60. And that should give me X all on its own. And so all we need to do is grab a calculator and type that in exactly. So 4 sine 40, close the bracket, over sine 60 equals, and there we go, we get an answer of 2.969. And if we have a look at that length of 2.969, it's practically 3 centimetres. Does that seem sensible given the size we already had? Well, given that this side was 4 centimetres, a side of 3 centimetres would seem very sensible for this question. If we tried again with the diagram, or with a 4 centimetre side, a 100 degree angle, a 45 degree angle, and a side called X, again we just need to decide, can we match up an angle with a side opposite it well there we go, 100 matches with the side we want to know, and 45, well that matches with the 4 centimetre side that we we already know. It makes that cross shape, and therefore the sine rule will work. And so we can use our sine formula. A over sine A equals B over sine B. But that means we actually need to label the diagram. So first of all, we'll call the 100 degrees A, which means that X, the side opposite it, is little a, and capital B for the angle 45, small b for the side 4 centimetres. And so, again, let's just fill in the values that we actually know. A is X. We don't know what that is, but capital A we know is 100, B we know is 4, and capital B is 45. And so, if I need to find X, the key is I just need to multiply by sine 100, and so X would be 4 sine 100 over sine 45. And again, I can just grab my calculator and type that in. So 4 sine 100 all over sine 45, and that comes to 5.571. And again, having a look at that diagram, well there's my 4 centimetre side. The X is obviously longer, but not that much longer. 5.571 sounds like a sensible result. So next we're going to try to find a missing angle in a triangle. And so once again we just need to do that first check, which is can we match an angle with the side which is opposite it? Well, here is the 3 centimetre side, it is opposite the 35 degrees, and the X, the angle we are trying to find, is opposite the 4 centimetres. It's formed the cross, so we can use the sine rule, but this time we're going to use the sine rule for finding an angle, which means that the angle goes on the top. So sine A over little a equals sine B over little b. And again, we just want to label our diagram, and let's call the angle here capital A, which makes the 3 centimetres little a, and we'll call X capital B, and so the 4 centimetres is little b. And we can just fill in all of this information. So sine 35 over 3 equals sine X over 4. Now this one does have a little bit more work to do with it, because first of all we need to isolate the sine X, and so that means we're going to have to multiply by 4, so that's going to be 4 sine 35 over 3 equals sine X. And finally, because we only actually want to find X, we need to use our inverse rule, just like we do with basic trigonometry in right angle triangles. If you're looking for an angle, then you need to use the inverse, and so we're going to have sine inverse of all of this information, 4 sine 35 over 3, and that should give me X all on its own. And so we're going to type all of that in. We're going to go for shift sign fraction, 4 sine 35, close that bracket, and over 3, close that bracket, and what we get is 49.886. 49.886 degrees would be X. And again, having a look at that, the angle, it should be bigger than the 35 based on what we've got drawn here, and it is, and so that sounds like a sensible result. Let's try it with one more. We're trying to find the angle X here, and we've got one side at 5 centimetres, one side at 1 centimetre, and an angle of 75 degrees given. Now first of all, once again, we just want to check, does the angle match a side? Well, the X matches with the 1, 75 matches with the 5. We can't quite see it because of the way it's drawn, but that does form the cross, and so the sine rule will work. So sine A over little a equals sine B over little b, And let's just label the diagram. Let's call X A, which makes the 1 centimetre little a. Let's call the 75 degrees B, and 5 centimetres little b. And so sine x over 1 equals sine 75 over 5. And so in this case, we want to isolate the sine x. So actually what we're going to do is nothing at all, because dividing by 1 just means as it is. So sine x equals sine 75 over 5. And therefore, to get x all on its own, I need to do the inverse sine of sine 75 over 5. And all I'm going to do is type that into my calculator to get the answer straight out. So shift sine fraction sine 75, close my bracket, over 5, close my bracket, equals, and that is telling me it's 11.139 degrees. And again, if we have a look here, 11 degrees is a very small angle. Let's look at what we've got there. 11.3 certainly seems to be a sensible result within that diagram. Okay, and so finally we're just going to have a look at some diagrams where we possibly have too much information, or at the start not enough information in order to answer the question, and how we would deal with that. So first of all, the same thing we've done every time. Can we match the side we want to know with an angle? Well, yes, we can. Can we match a side with an angle? Well, 3 centimetres would match with 35 centimetres. And can we match a side with an angle? Well, 4 centimetres has no angle to match with it. But if we really wanted to, we could actually work out that angle, because we always know that the angles in those triangles must add up to 180. So 95 plus 35 would be 130. So that one would be 50 degrees. And so with that, we've actually now shown we've got the full set of A, B and C. We can use any of them. But what I would always suggest is trying to use the ones where you already had all of the information. And so in this case, we're going to limit what we're actually dealing with to A and little a, B and little b. We'll actually ignore the 4 centimetres for this time, because we only ever need one pair. And so this one is finding a side. So I'm going to have A over sine A equals B over sine B. And so little a is x sine capital A is 95, and B is 3 over sine 35. And so if we want to work out what x is, well, I'm going to have to multiply by sine 95, and so x will be 3 sine 95 over sine 35. And again, this is just a case of typing it straight into your calculator. So let's grab the calculator. 3 sine 95 all over sine 35. And that comes to 5.21 centimetres. Let's just have a check. Do we think that is sensible? Well, the other sides were 4 centimetres, 3 centimetres. 5.21 sounds like a sensible size for that. Next, we have x 5 centimetres, 9 centimetres, and we have a 30 degree angle and a 70 degree angle. Now in this case, the side we want to know is x. Can we match that with the angle opposite? Well, we come to a problem immediately. The angle that is opposite x is not there, but that is not a problem in this case, because all we need to do is we need to work out what that angle must be. The angles in the triangle must add up to 180, so 30 plus 70 is 100, therefore that angle must be 80 degrees. We now have an angle which matches with the side we were looking for, and we also have an angle matched with a side, and we do in fact have the third one as well, but we only ever need one pair of sets. And so we're trying to find a side, so we're going to call it x over sine 80 equals 9 over sine 70. And so if I want to get x all on its own, well, I'm going to multiply by sine 80. So that's going to be 9 sine 80 over sine 70. Just type that all straight into the calculator. We're going to have 9 sine 80 all over sine 70, and that gives us 9.432 centimetres. And again, if we have a look at that, it would seem a very sensible answer given that the other sides were 9 and 5. They've got to be in roughly the same sort of area. And finally, I just want to point out one thing that is very important with the sine rule, and that is obtuse angles. We've got to be very careful when we get our answers for obtuse angles, and I'm going to show you why that is the case. If we have a look, we have our pair, an angle matched with its side, and an angle matched with its side. And so that would tell us, in this case, that if I wanted to find this angle, I would have sine x all over 9 would be equal to sine 30 all over 5. And therefore, sine x would equal 9 sine 30 over 5. And x would then be the inverse of that, so sine inverse of 9 sine 30 over 5. And if we type that into our calculator, we get shift sine of 9 sine 30 all over 5, close the bracket, and it tells me that the answer is 64.158. Now, quite clearly, this is not an acute angle. It is an obtuse angle, and what you must recognise here is that this is not actually the correct answer. The correct answer is then 180 take away the acute version, because what happens here, this is actually dealing with the same situation as if I added the line 5 centimetres here. It's finding this angle here in the triangle, because the calculator doesn't recognise the shape of the triangle originally. So we need to understand that if it is an obtuse angle, we have to take the complement of it. So 180 take away 64.158, go to our calculator, take away answer, and we get 115.842. So 115.842 degrees, and that is the size of the obtuse angle in this case. And finally we come to the exam question, and this one actually came from the EDUCAS exam sample paper, and we were given a set of parallel lines, the diagram not drawn to scale, and we're told that AB is parallel to ED, and we want to calculate the length of AB. So this is the length we are dealing with, trying to find. Now at this stage we have no angles involved whatsoever, but what we need to think about is the information we have been given in terms of this being parallel lines. And the key here is that when we are dealing with parallel lines, we need to be thinking about, do we have Z shapes, do we have F shapes, and so on. So in this case we have alternate angles. We have a Z shape. So if this angle is 80 degrees, then this angle is 80 degrees as well. If we think of it in the other direction, the same applies. If I go along here, these are also alternate angles, and therefore if this one is 40 degrees, then this one is 40 degrees. And therefore we've got two sides. The other thing, we can also work out the missing angle because it's a triangle. So 80 and 40 is 120, so that must be 60 degrees in here. And the idea is that we were trying to find the length of AB. So the question is, do we now, in that triangle, ABC, do we have those pairing up of angles? Well, we've got 60 degrees here with the side that we want to know. So there is one pair. And we know that this length is 6 centimetres. And we also know that that one is 40. And so there we have that cross. And so we can use the exact same formula we've been using all throughout this video. We can say that x over sine 60 is the same as 6 over sine 40. Therefore x is 6 sine 60 over sine 40. And so all we're going to do is type that straight into the calculator and see if we can get our answer. 6 sine 60 all over sine 40 equals 8.084. 8.084. Were we asked for any particular level of accuracy? No, we weren't. And so 8.084 would be absolutely fine.